Welcome back to our Basic Construction Knowledge series. In this segment, we're going to discuss wall systems. Platform framing and balloon framing systems are very similar in many ways. Balloon framing was used more commonly years ago when power tools were not available on job sites and all lumber needed to be cut by hand. As electricity became available and cutting lumber on site was made easy with power tools, platform framing, which is a more efficient, stronger wall framing method, became more prevalent. It is the most common method used today. In platform framing, the wall systems are framed on top of a floor system that acts as a platform to support the floor and roof systems above. In these systems, the walls are typically only 1 story high, which allows them to be much more stable and prone from twisting and warping. These shorter walls are easier to build on site and stand up. Platform framing works in many applications, and material sizes and lengths needed are very common. There are, however, situations where balloon framing is preferred or necessary. A balloon framed wall system is framed at full height from either the foundation or the floor that is supporting it to the floor or roof system above uninterrupted. It is used in tall wall systems or multi-story areas for many different reasons. Multi-story areas on homes and buildings are often considered balloon framed. Any floor systems that are supported within the balloon framed area would be ledgered or let into the wall. Many times curtain walls on exterior or multi-story projects must be balloon framed to support loads above and provide the higher fire ratings needed. We will discuss these types of systems in more depth in later segments. Post and beam framing was covered to some degree in our floor system segment. This system was used in the past to frame many structures when lumber was not yet available from lumberyards and suppliers in pre-milled lengths and sizes as it is today. Old barns are many times post and beam construction. The walls in a post and beam system are comprised of structural posts that support beams that in turn support the floors and/or roof systems above them. There are many modern-day applications that require post and beam wall systems as well. A pole barn is a good example of modern-day post and beam wall construction. Walls are either constructed with siding installed directly onto horizontal furring strips that span between the posts, or can be infilled between the posts and sheathed as with standard platform or balloon framed walls. Post and beam framing is typically used in specific applications that call for it for aesthetics or functionality. The most common material used to frame all of these systems in residential construction is lumber. These are the systems and products that we will discuss today. Platform frame wall systems and balloon frame wall systems use basically the same components. These are plates, studs, headers, sheathing, fasteners, and connectors. Typically, there are 3 plates used in a wall system. There's a single bottom plate and 2 top plates. The bottom plate sits directly on top of the floor below. If the floor below is a wood-framed floor system, then the bottom plates are the same lumber used as the studs and top plates. If the floor below is concrete, the bottom plate is typically made from pressure-treated lumber. This is the case in a slab-on-grade floor system with a wall system framed on top of it. Wall systems can be framed from any width or depth of lumber desired, but are typically made from 2x4 or 2x6 material, depending on the intended application. In an exterior wall system, 2x6 material is often used because it is stronger and provides more insulation value in the wall cavity. A typical exterior wall system would have a 2x6 bottom plate, 2x6 studs, and 2 2x6 top plates. Openings in the wall system would be supported by headers, which are in turn supported by jack studs. Studs can be any length necessary for the desired height of the wall system. However, in today's market, most studs are pre-cut lengths. Pre-cut means that the studs have been precision trimmed at the mill so that they are exactly the same length and do not need to be cut on site. Typical residential walls are called out as 8 foot, 9 foot, or 10 foot high. These are the most common wall heights called out on plans. However, they are not the exact height that the walls frame out to be. For example, in a 9 foot high wall system, there are 3 plates. Each plate is 1.5 inches thick. Sitting atop the 1.5 inch bottom plate is a 9 foot pre-cut stud. While you may think that a 9 foot pre-cut stud is 108 inches, it's not. A 9 foot pre-cut stud measures 104 5/8 inches. Atop this pre-cut stud, there are 2 more top plates that, like the bottom, measure 1.5 inches each. This means that the height of a 9-foot wall using a 9-foot pre-cut studs is actually 108 and an eighth inches. This height allows drywall to be installed on the ceiling and interior side of the wall without having to cut the sheets. The same principles apply to 8-foot and 10-foot pre-cut studs. 8-foot pre-cut studs measure 92 and 5/8 inches, 9-foot pre-cut studs measure 104 and 5/8 inches, and 10-foot pre-cut studs measure 116 and 5/8 inches. Walls are typically assembled on site by laying a bottom plate on its side and nailing the studs at 16 or 24 inches on center to that bottom plate. Once the studs are nailed, a top plate is applied the same way. The walls are then stood up and attached to the floor below with a single top plate. Once the walls are assembled, a second top plate is applied that overlaps the joints where the walls come together at corners and interior intersections. When openings are required for doors, a stud is placed at each side of the door opening that is high enough to accommodate the rough opening of the door. This is called a jack or trimmer stud. A full height stud or king stud is then attached to the jack stud. A component called a header is then placed on top of the jack stud and attached through the king stud. After assembled, the bottom plate at all door openings are typically cut out. Window openings are framed in a very similar way, with the difference being a sill plate is attached to the jack stud at the bottom of the window rough opening height. On window and door openings, if the header isn't the exact size from the top of the jack stud to the bottom of the bottom top plate, then shorter studs, called cripple studs, are placed between the header and the bottom of the top plate. On a window opening, this must also be done between the bottom of the sill for the window and the top of the bottom plate. Headers are basically beams designed to support the load above an opening in a wall. They are designed and specified by the architect or engineer on record. Many times, typical headers will be specified on door openings and window openings as 2x4, 2x6, 2x8, 2x10, or 2x12 material nailed together. A typical 2x4 wall is 3.5 inches wide. Since the header material, 2x6 through 2x12, measures 1.5 inches wide, when nailed together you would only get 3 inches. Therefore, many times a piece of 1/2 inch plywood or OSB is placed between the two pieces of lumber to provide the additional spacing as well as strength. The same system can be used in 2x6 walls. Instead of 2 pieces of lumber, 3 pieces with 2 1/2 inch plywood spacers between each ply is used. The size and number of plies of load-bearing headers will depend on the size of the opening and the load it is supporting and should be specified by the architect or engineer. Many times, headers made from engineered wood products or even structural steel must be used above wider openings or to support larger loads above. Engineered beams used as headers should always be specified by an architect or engineer. Where walls intersect and tie to each other and where corners are needed, several methods can be used to provide the support, nailing for drywall and sheathing, and insulation required. Corners and pockets for intersecting walls can be blocked solid or framed several ways to provide space for insulation. It is up to the architect, engineer, and/or framer to determine the system used. Either way, additional studs and blocking must be figured in for these areas. In typical residential construction, sheathing refers to the sheet material used on the exterior surface of the wall. Sheathing provides strength, fire resistance, moisture resistance, and insulating properties to the wall system. A generic term for sheathing material is plywood. However, this is a specific type of sheathing that is manufactured from plies of veneered lumber. OSB, or oriented strand board, which is similar to plywood but is manufactured from stranded veneers of lumber, is another material that is commonly used that is usually a less expensive option. Each product has its own features and benefits depending on how and where it will be used. There are many other types of sheathing that provide additional structural integrity, fire resistance, R-value, and weatherproofing to exterior wall assemblies. These products will be covered in later episodes. Walls can be sheathed either on the ground during the assembly process or after they have been installed. The walls must be level and square prior to sheathing. Once attached to the subfloor, walls can then be braced level and plumb. Walls are typically nailed together with pneumatic nailers that drive nails through the bottom plate into the stud and through the top plate into the stud. The sheathing is then nailed through the sheathing panel into the studs and plates. Many times, nailing sizes and patterns are specified on plans so that sheathings are nailed in a way to provide the proper support needed in higher wind load areas. Additional bracing and/or sheathing is sometimes required on walls for extra support. This is known as a shear wall or braced wall assembly. Hold downs, metal strapping, or steel connectors are used to secure the wall to the floor or wall systems below. They're usually fastened to the bottom of a corner stud or a jack stud in the openings. They are then bolted through the bottom plate of the wall, either into concrete slab, floor system, or wall below. Strapping is used between the floors, either inside or outside, to attach the wall systems and floors together. This concludes the segment on basic wall systems and assemblies. While there are many other systems and materials that are widely used in construction, these wood-framed wall systems are the most common. We will discuss other more complex assemblies in later episodes, as well as dive deeper into all of the components and materials available. Thanks for watching, and stay tuned for our next segment on roof systems.